All right, today we're going to take a look at multi-step problems involving special right triangles, which are our 45, 45, 90 right triangles and our 30, 60, 90 right triangles. So here we have two triangles that are sharing a side. This one's a 45, 45, 90 right triangle, because if that's 45 degrees, so is this. I always suggest penning in or penciling in what the degrees are, what your angles are. And this one is a 30, 60, 90, because if this is 60, that's our 90 degrees, this has to be 30. That way you can see everything. And as you can see, they share the side, which is Z. And that side is the hypotenuse of the 45, 45, 90, but it is the long leg, because it's opposite the 60-degree angle of the 30, 60, 90. All right, so our goal is to use the only information we have, which is this leg right here of the 45, 45, 90 right triangle, which is 9 radical 3. Now, 45, 45, 90 right triangles are equal sides. They have equal sides opposite those 45-degree angles. So right away we know y is 9 root 3. So I'll just write a running list over here. All right, and then we need to get x and we need to get z as our final answers. Okay, now, to get z of our 45, 45, 90 right triangle, it is the hypotenuse, and the rule is for 45, 45, 90 right triangles that you take the leg times radical 2, and that will give you the hypotenuse. All right, that's in our 45, 45, 90. So our leg is 9 root 3. We're going to times it by root 2, and we'll get our hypotenuse, which is z. So this is going to give us 9 square root of 6, and that equals to z. So I'm going to write that on here so we can see it. And I'm also going to then put my running list over here for checking answers right there. All right, now our goal is to get x. And x is the hypotenuse of the 30, 60, 90 right triangle. So therefore, I need the short leg. Even though we're not asking for it, remember that the short leg times 2 gives us the hypotenuse. So our hypotenuse for our 30, 60, 90 is 2 times our short leg. So we need our short leg first. So to get our short leg, we're going to have to use our long leg, which is equal to the short leg times radical 3. All right, well, we know our long leg is 9 root 6, because that's opposite our 60-degree angle. We don't know our short leg. I'm going to call it W, just so I have a variable for it. Although don't have to find it for an answer to this problem. I need it to find one of those answers, so I'm going to call it W, and then times root 3. Then I'm going to divide by root 3 on each side. And because these are both inside radicals, the 6 and the 3, we can divide them as we do any number. Keep the 9 outside. 6 divided by 3 is 2, but it's still under the radical. And that equals to W, because these guys cancel to 1. So our short leg is 9 root 2. So now to get our hypotenuse, okay, which is 2 times our short leg, our hypotenuse is x, and 2 times our short leg is 2 times 9 root 2. 2 and 9 are outside the radical, so they're 18, and you keep the radical of root 2. So x is 18 root 2. And we'll put that up there on our running list for a quick check. But all of our work is here, and we've written onto our figure so that we can visualize it as we're working through each of these problems. All right, let's take a look at another one. Okay. Put some degrees on here. This one would be our 30-degree angle. Okay. All right, so here we have a 45, 45, 90 right triangle, and then this one is a 30, 60, 90 right triangle. Now, this is 60 degrees, so we'll fill it in, and this is 45 degrees, and fill it in. And remember, these aren't drawn to scale. They're sketches, but you want to put the information on here. All right, what we do know is our two legs, x and y, are going to be equal. I'm sorry, z and y are going to be equal because they're opposite our 45-degree angles. So z equals y. and we'll find out what that is in a little bit. Now, x is the hypotenuse of our 45, 90 right triangle, so right now we don't have any information to get it. So we have to back up and work in our 30, 60, 90 right triangle first. All right, so we need w, which is opposite our small side. We have our longest side of 9 root 2. So what we're going to do is take this for our 30, 60, 90 right triangle, is that our short side, long leg, is equal to our short leg times root 3. So we have our long leg of 9 root 2. Our short leg is w, and this is root 3 times root 3. So now we're going to divide by root 3 on each side so we can find out what our short leg is. All right, now our w is going to be 9 root 2 over root 3. We can't have a radical in the denominator, so therefore we're going to have to rationalize it. And we rationalize by multiplying by the denominator's radical, but in the form of the number 1. So root 3 over root 3. So this is going to give us 9 root 6 over root 3 times root 3 is root 9, so it comes out as 3. Now 9 and 3 are outside the radical, so we can divide them. So our final answer for w, which is our short leg, is 3 root 6. So we're going to put that on our figure. Okay, 3 root 6. And let's keep our running tab here on our variables. And we got that. All right, now we need to get z. Z in a 30, 60, 90 right triangle is the hypotenuse. So our hypotenuse equals 2 times our short leg. Our hypotenuse is z. It's 2 times our short leg. Our short leg is 3 root 6, so it's 2 times that. So z is going to equal 6 root 6. And since y is equal to z, then it is the same thing. So y and z are both equal to 6 root 6. And now we have to find x, which is the hypotenuse of the 45, 45, 90 right triangle. So now we're working in this triangle exclusively. And we take a leg and we times it by root 2, and we get our hypotenuse. So our hypotenuse is x. Our leg is 6 root 6. We're going to times it by root 2. So x equals 6 times root 12. Well, root 12 has a perfect square in it. This can break down into 6 root 4 times root 3. And root 4 is our first perfect square. Okay, because we don't count the square root of 1 because it doesn't change anything. So x is going to equal the 6 times, the square root of 4 comes out as a 2. And square root of 3 is not perfect, so it stays root 3. So this is going to give us 12 root 3. So x is 12 root 3. And so now we can write up our running list. X equals 12 root 3. All right, here's all of our work. Everything's put on our diagram so we can see it on our figure. And here's our running list of answers for quick checking. All right, and one more problem. We have a 30, 60, 90 right triangle here. All right, so we'll put in our right angle, because if it's right on that side, it would be supplementary on this line. So we have another 90. So 30 is here, and then 45 would be here. So start marking our diagram. We know that this side, y, is equal to z, because they're opposite the 45, 45 degree angles. And the only information we're given is the hypotenuse of the 45 degree angle. All right, so what we're going to do is our hypotenuse in our 45, 45, 90 degree triangle is equal to a leg times radical 2. We have the hypotenuse is 5 root 6. We'll pick one of the legs. It could be x or I'm sorry, z or y. It's up to you. So I'll use z. Okay, just for fun. All right, so now we're going to divide by root 2 on each side. And we're going to get 5 roots 3 equals z. And I'm going to write that here, 5 root 3. And since y is the same, it's 5 root 3. So y equals z, which equals 5 root 3. Keep our running list. All right, now we need to get our short side, which is x on a 30, 60, 90 right triangle, and our hypotenuse. All right, so we know that the long leg of our 30, 60, 90 right triangle is 5 root 3, and our long leg equals to our short leg times root 3. So our long leg is 5 root 3. Our short leg is x, because it's opposite our 30-degree angle. If we times it by root 3, we get the long leg. So we divide by root 3. And x equals 5. So that's pretty nice. So we have 5 here. And to get our hypotenuse, it's 2 times the short leg. So w is our hypotenuse. And it's 2 times 5. So w equals 10. We put that here. And keeping our running list, x is equal to 5, and w is equal to 10. So we have everything, and that's how you solve multi-step problems involving the special right triangles.